Okay, so we are live. So this is day one of the challenge. And when I uploaded the video and when I saw the comment section, a lot of people mentioned that it's not about MacBook, it's all about learning. So yeah, that was the intention. It's more about motivating you to learn more, to code more, right? And a lot of time we have this tendency of thinking, hey, we can do it later. And that's the thing. Just wanted to know if I'm properly visible and I'm properly audible before we start. Okay, volume is low, is it? What's wrong with the volume? I think it's. Harsh, can you check the volume, please? Noise. Let me check. But why it is low? Is it picking the right mic? Hello, hello. I think it's picking the wrong mic. Hello, hello, hello. Yeah, I think it's good now. Sorry for this problem. There was some issue with the sound system. Now let me know if it is good. I think it should be good now. Okay, still complaints about the noise, is it? Hello, hello, hello. Yeah, I think it's okay. It's proper, right? Okay, cool. So there was some issue with the sound setting and now I think it's all set. So welcome once again. So even before we start, I want everyone on YouTube to join because it takes time for YouTube to send the video. So we'll start in next 2 minutes. So we are going for a break of 2 minutes and we'll connect exactly in 2 minutes. Okay, so I'm back and let me know if there's still some noise because I think everything is good from my side. Okay. Okay. So before we start, there's a question: how long is this live? So basically, this is the 10-day live. No, okay, we are not going live continuously for 10 days. Basically, we have a live for 1 hour daily, approximately 1 hour. I'm not sure how long it will go, but that's the plan. Okay, so before we start, we can just give. You can just hit the like button. Yeah, so that will motivate me. Okay, so let me just give you a plan. What is the plan for this particular sessions? So the plan is very simple. For the next 10 days, I will be going live on YouTube to teach you different concepts, mostly in Java. So there are some concepts which are there in every language. It's just that we are going to see examples in Java. So even if you are from different background, let's say JavaScript or Python, this concept will be still relevant. Example, in today's topic, when we talk about recursion and memoization, so it's very tricky to pronounce it. So there's always a confusion between memorization and memoization. So yeah, we're going to talk about memoization, which you can implement in any language. It's just that we are going to do that in Java. And every day we are going to talk about different things. In some days, we might talk about some projects. We'll try to build a project, simple project, but the idea should be different. It's not about code. It's more about how do you think? How do you implement something in programming? So that's what we're going to do. So daily, the plan is to go for 1 hour. Okay, I'm just make sure my system is set up before we start. There are certain things we left out. Okay, cool. So I hope you are excited for this live sessions and okay, so excited to learn from you more than the MacBook. Oh, thank you so much, Vinyas. I hope that's how I pronounce your name. Cool. So thank you so much, and let's begin the learning. So let's talk about what we are going to do today. Okay, yeah. Okay, so let me share my screen and let's talk about what we are going to see. So let me share my screen. Okay, now this is the agenda. Okay, so basically we are going to talk about, so this is day one. We are going to talk about recursion, memoization. Okay, and examples will be done in Java. That's the plan. And yeah, so this is what we're going to do in detail. This is the plan. Initially, we'll start talking about recursion. Then we'll move towards a concept of how do you implement recursion with the help of factorial, and then we'll move towards Fibonacci, that's how you pronounce, and then we'll focus on memoization. Now, in terms of factorial, I will need your help. I mean, of course, we can write factorial code, but I want your help to do this. Okay, and then we are going to focus on Fibonacci with memoization. And then we'll focus on the assignments. Okay, now why we have this assignment? For two reasons. One, this assignment will be helpful for you to learn something new and implement. Because see, in this sessions, I'm going to teach you recursion memoization with example, and I will give you another example to implement the same thing with the help of recursion and memoization. And yeah, so that's the assignment, and you have to submit that assignment on GitHub. So basically, if you do assignment, that's your choice, that's your learning. But if you are here for learning purpose, then make sure that you are doing some stuff. So if you want to compete in this competition of a MacBook, if you want to win a MacBook, I want your engagement. Winner will be based on the engagement you show. Now, how do you show the engagement? First, you have to attend the live session. You have to be active in the chat. Next, you have to you have to complete the assignments and publish the assignment on GitHub. Next, write the article and on whatever we have learned, because it's also about, sometimes you think you know things, right? And it happens with me a lot. Sometimes I feel I know stuff, and how do I know if I know a concept or not is by teaching. So the moment I try teaching a concept, and if I can't explain, that means I'm not fully understood this concept. So you have to explain. Now, how do you explain to someone else? There are two options. One is YouTube, and second, let me just close my WhatsApp. It's making some noise here. Where is my pointer? It's here. Quit WhatsApp. Yeah. So yeah, so basically you have two choices. One, you can teach on YouTube. So create your own channel, upload the video of the concept, and okay, I will not hit any copyright strike, don't worry. You can talk about the same concept there, and do tag me there so that we can track you. Otherwise, you can also write an article on LinkedIn, and you can tag me there as well. So you have two choices, okay? Currently, we are going for these two options. In future, if we feel we have more options, we can do that. Okay. So I hope you're all set. So basically, if you want to know my handles, you can see on the screen. LinkedIn is Naveen Reddy 20. Instagram is Naveen Reddy Official. Our website is telusko.com. We also have a Discord server. So if you want to connect and if you want to do together, if you want to solve the assignments together, you can also connect. Also follow us on Discord. You can join the group or the channel, which is Telusko. And yeah, everyone knows the YouTube channel Telusko. So yeah, that's the thing. Okay, so with that, let me start with the implementation. Let's start about factorial. So let me know if you have any questions in the chat so that I can answer that before we start. And also let me know how many of you know this concept of, okay, my WhatsApp is still running. That's crazy. So actually I have two machines. I'm not sure which WhatsApp was running. Let me just close. How do I close my WhatsApp here? No issue. Ignore the WhatsApp icons there. Hush. Okay, remove iMac from my mobile. WhatsApp. Okay, cool. So let's talk about it. So let me share my iPad once again so that I can show you what we're going to talk about. And iPad is 5. Okay. So let's talk about a concept of recursion. Now, what exactly recursion means? Let's say if you have a function, let's say the function name is ABC. I know that's a weird name of naming a function, but let's say you have a function ABC. And then in this function definition, you are calling ABC again. So ABC, so someone is calling ABC, let's say you have a main method here, and inside this main, basically you are calling ABC. Now, when you call ABC from here, of course, this particular function will be called, and the same function is calling the same function. You know, I don't know if you have seen that movie, the Bollywood movie, which is Karthik calling Karthik. So that sounds like this. So this is a function is calling a function. That's what's happening here. Now this concept of function is calling a function is called recursion. Okay. Now how exactly it looks like in Java? Let's talk about it. So let's say you have in Java, if you know, there's a memory, right? So you have a JVM. Inside JVM, you have different type of memories. Now one of the memory there is a stack. Okay. So there is a stack, and this is where you call the functions, right? Now, if we talk about a concept about recursion, what happens is when you call a function, so a function is calling a function, right? Okay, I'm writing at the wrong place maybe. I just need to switch it here. Okay. So when you have a function calling a function, what happens is, example, let's say when you say ABC, I should use a different function name. Let's say the function A, and inside function A, you're calling the same function. Now, what is happening is, when you call the function for the first time, like when you call A, it will be here. Now the same function is calling the same function, right? In that case, it will, of course, it will have its own stack, but just for simplification, you are basically calling the functions. Okay, so the function is calling a function, the function is calling a function, the function is calling a function. Okay, this is what recursion is. But then why in this world we have this concept of recursion? That's the first question we have, right? Why do we even have recursion, right? And that's what we are going to see here. Okay, Ecamm live. Just a second, I'm setting my stuff. Okay, yeah, so why in this world we have this concept of function calling a function? Now to understand this, let's do an example here, and let's do it for the factorial. So what I will do is I just want to check if everything is going well on YouTube. Okay, so let's do an example here, and that example will be of factorial. Now, what is factorial, by the way, everyone? So when I say we are working with factorial, what it means? Hush, is this still noise coming from the video? No, no noise. Okay, multiplication of 1. Bye का phone है. Okay, from morning I was so free, no call, no WhatsApp, and suddenly the moment I went live, I'm getting all the calls, all the messages. Weird. Yeah, let's talk about factorial. So what is factorial basically is, example, let's say if I say 5 factorial. Now this is a mathematical problem. So let's say if you have 5 factorial, what it means is, so basically exclamation mark you use for factorial. So 5 factorial means 5 into 4 into 3 into 2 into 1. Okay, that is your factorial. Right? And the answer would be, so we have to multiply 5 by 4, which is 20. 20 into 3 is 60. 60 into 2 is 120. 120 into 1 is 120. So the answer is 120. Okay. So this is how you find a factorial. Of course, you can find it for 6 factorial. So what is 6 factorial? So 6 factorial is 6 into 5 into 4 into 3 into 2 into 1. Okay, so 6 factorial is 6 into 5, which is 30. 30 into 4 is, what is 30 into 4? I'm so bad with maths nowadays. 30 into 4 is 120. Is it 120? 30 into 4 is 120, yeah. 120 into 3 is 360. 360 into 2 is 720. So 720 is the answer. Let me know if that is the right answer. Yeah. Okay, so this is how you want, this is what you want to do in programming. So what I will do is, I will just create a new project. Let me share my screen. Okay, so basically I was doing some experiment before this session. So what I will do is I will just go back here. Yeah, and let me create a new project. So basically we are creating a new project. So the IDE which I'm using is IntelliJ IDEA. Yeah. Okay. So let me create a project for Java codes, and the language is Java. IDEA. Okay. Build system is IntelliJ. Okay. Create this window. Okay. So basically we got a file. Let me increase the font size a bit. Is this visible? Settings. And appearance. Nothing changed. Weird. Yeah, this is good. Is the font size good, or should I increase by 150? This is good, right? The font size. Sorry. Increase bit more. Bit more. Screen के बाहर आ जाएगा. Okay, let's use this font size. This is good. Okay. So what we will do is we want to find the output, right? So basically we have a factorial here. So what I will do is I will just go back and say factorial. That's what we want to find. Okay. Now, in terms of programming, how we are going to do it? So what I will do is, first of all, I will take a number, the number of which I want to find a factorial. Let's say 5. We'll start with 5 initially, and then we are going to. I will save the result in result. So I will say int result is equal to, and in this, basically the initial value of result will be 0, and then at the end, I want to print result. Okay. This is the simple thing I'm doing here. And then I want to change the value for result. So this result should be equal to the factorial value. Of course, the factorial of 5 is not 0, because if you run this code, it will be 0. I want to change it. So what I will do is I will call a function called fact, And in that function, I'm passing a number 5. And then this function should give me the value of result. As simple as that. This is what we want. This is what we want. All good? Okay. So basically what I'm doing is, I got two variables here. I got num, I got result. And then in this result, I want to store the factorial of 5. And this is a function which will give me the factorial, right? Okay, but then we don't have this function, right? So what I will do is I will create this function. So I will say public static void, not void, because this function will return an int value. So I will say int, and the function name is fact. And then in this fact, I'm going to accept the value, which is num, let's say. And here, initially let me return 0 so that there is no error. Okay, now how do you find a factorial? So let's say if you want to do the same thing, you have this 5 into 4 into 3 into 2 into 1. Example, if I type here, if I say 5 factorial is equal to 5 into 4 into 3 into 2 into 1, right? So this is the factorial of 5. So basically what we do is we have to start, or maybe you can also write in reverse order if you want. Example 1 into 2 into 3 into 4 into 5. Both are the same thing, right? So how do you do this? So what we can do is here, we can start with 1 and we can multiply 1 by 2. Then we can multiply the result with 3. We can multiply the result of that with 4. We can multiply the result of that with 5. So what I'm saying is first try 1 and 2. The output of this will be multiplied by 3. The output of this, the entire stuff, will be multiplied by 4. And the output of the entire stuff will be multiplied by 5. To achieve that, we can use a loop here. Or maybe I just need a variable so that I can store the temporary value of factorial. I will say temp. Or maybe a different value. Let's say value. Is initial value of this will be 1. And then what I'm doing is, I need to start a loop because we want to iterate the values, right? So I will say int I is equal to 1. We start with 1. And I less than equal to 5 because we have to also mention the ending point and I plus plus. Right? Okay. We got extra semicolon there. And every time you multiply, so what you have to do is we have to say value is equal to value multiplied by I. So if you observe what I'm doing is whatever value of example, let's say initial value of value is 1 and then 1 into value of I, which is 1. So 1 into 1 is 1. And then the loop iterates. The value of I becomes 2 now, right? And then 2 into 1 is 2. So the same thing we are doing. Whatever we have done on the top here, we are doing the same thing. But how do you do that? So there's one more change of 5 here. It should be num, right? Because we have to reach till that point. And then whatever the output is, we'll print it here. Okay. So if I run this code now, let's see what happens. If I just run this main, and let me just move this to the right top. This looks good. Yeah. So you can see the output is 120 and that's what we're expecting, right? 5 factorial is 120. If you change this number, let's say if you make it 6 and if you say save and if you run this code, you can see we got, okay, the number is not changing because we are passing 5, we should pass num, my bad, and save, and you can see we got 720. If you go with a bigger number, let's say 7, and if you run this, you will see it's 5040. Yeah. So basically, this is how you work with this. Yeah. Okay. This is factorial, right? But there's a better way of doing this. So this is normal iteration. So normally this type of methods on this type of way is called iterations, right? You can do the same thing with the help of a recursion. Now, how do you do this with the help of recursion? That's what we're going to see now. So what we can do is this code, which is mentioned here, what I will do is I will just comment this so that you can use it later. And let's do this once again. Let me say return 0. So what I will do is instead of using iteration, can we do this? If you go back to the earlier method of doing this, 5 into 4 into 3 into 2 into 1, if you observe the 5 factorial, don't you think the 5 factorial is actually 5 into 4 factorial? Is this making sense? Instead of saying 5 into 4 into 3 into 2 into 1, we can say 5 into 4 factorial. Because what is 4 factorial? 4 factorial is this. So we can also say, what is 4 factorial? So 4 factorial is equal to 4 into 3 factorial, right? So if you can implement the same concept in programming, how will you do it? It's very simple. If you observe, this is one function and this is a function as well, and both are factorial. It's just that if you want to calculate the factorial of 5, you need to calculate the factorial of 4 first, right? So can we do this? Can I say int value? What's wrong with my keyboard? Int value is equal to, let's say, 1. And then we'll simply multiply. I can simply say return value into, or maybe I can do this. I can say num, because that's what we are getting, right? Num is 5. So if you get 5, so it should be 5, which is here. If you observe this line, to find the factorial of 5, you have to say 5 into 4 factorial. So return num into factorial of 4. What is 4? How do I represent 4 here? I don't want to hard code it. Can I say num minus 1? Will that work? So 5 factorial is 5 into 4 factorial. So we just need to return 5 into factorial of 4. Right? Does it make sense? Okay. But question is, will this work? Let me remove this val, not read it. The question is, will this work? So what is happening is, to find the factorial of 4, we are saying 5 into 4 factorial. To find the factorial of 4, we have to say 4 into 3 factorial. To find the factorial of 3, we have to say 3 into 2 factorial. To find the factorial of 2, we have to say 2 into 1 factorial. To find the factorial of 1, you have to say 1 into 0 factorial. Oh, that's weird now. And when you say 0 factorial, we have to say 0 into minus 1 factorial. Oh, there's no ending. We have to end at 1, right? If you can see, we have to end at 1. How do you do that? We can do one thing. We can check if the value for num is equal to 1, just return 1. Does this make sense now? So we are ending at 1 now. And let me check if this works. Run, and it works. You can see we got 5040. And if you say 6, you can say 720, right? So we also have a concept of recursion. So what we are doing in recursion is we are calling a function by itself. So basically we have two options. We can use iteration like loops, which we have used. And the second option we have is factorial, the recursion. Does this make sense? Okay, cool. Number 0 base condition. Yeah, actually we can also do it till 0, because the reason we can do it for 0 is because what if someone wants a factorial of 0 and the factorial of 0 is 1? right? So we can do this as well. Even this works. Let me try. And even this works. Yeah. Okay. So this is the example for factorial, right? So we can use iteration, and we can also use recursion, right? Now, since we understood the concept of recursion, right? Let's go for a next step. For the next step, let's do an example of different stuff. Well, let's talk about Fibonacci. Okay. And before we understand the concept of Fibonacci, let me talk about the concept of what is Fibonacci. Come on, you can also help me in the chat. What is Fibonacci? Yeah, actually, there's a question. I think recursion takes more memory than loop. That's true, is because recursion will use a different stack. So it will consume more memory. See, in programming, it's all about a trade-off, right? So do you want to consume more CPU or do you want to consume more RAM, right? Okay, why to use recursion? Because recursion looks cool, right? It consumes less number of lines. And there are certain use cases where recursion make much more sense. And not everywhere, okay? So don't think from tomorrow you are only going to use recursions. Okay. Krish says, check your network problem. Is it issues with everyone or network is good?
Yeah, network is good.
Okay. Okay, let's talk about Fibonacci now, or Fibonacci. So if we talk about Fibonacci, so what is Fibonacci? Okay. Now, Fibonacci simply says, this is a Fibonacci sequence. And 21, 34, and list goes on. So this is basically a Fibonacci sequence. Now, how do you create the sequence? It's very simple. The first two numbers are confirmed. So the first two numbers for Fibonacci series is 0 and 1. Now, whatever numbers are coming up after 0 and 1 is the addition of the previous two numbers. Example, if you want this one, you have to add this 2. If you want to get 2, you need to add this 2. So basically the 1 and 1 is 2. Example, 0 and 1 is fixed. Then add 0, 1, which is 1. Then add 1, 1, which is 2. Then add 1, 2, which is 3. Then add 2, 3, which is 5. Then 3, 5 is 8. Then 5, 8 is 13. 8 and 13 is 21. So this is basically a Fibonacci series, right? So, and you can go with a very big number, doesn't matter. So this is Fibonacci. Now, how do you do that in programming? Okay, so to achieve that, what we can do is we can use a loop. Of course, we can use iterations. First of all, everyone got this, right? What is a Fibonacci series? So if you want to achieve this in programming, what we can do is, it's very simple actually. You can take two variables, A and B, right? The initial value of A will be 0. Initial value of B will be 1, right? And then you can take another variable, which is C, and you can say C is equal to A plus B, and you will get the third value. So you got 1 because 0 plus 1 is 1. Now, once you got the value, the next value, what you can do is you can simply swap the values of A and B to the next value. Initially, A and B was 0 and 1. Now, A and B is 1 and 1. Basically, is it making sense? Initially, A was pointing to 0 and B was pointing to 1. But now, after getting the third value, A will point to 1 and B will also point to 1. And let's say after the iteration you got 2 as well, then A will point to the next number, which is 1, and B will point to 2. And then again you will add, you will get 3. Simple stuff, right? Just iterate. So how do you do this in programming? Let's implement. So let me go back to my screen, and here I want a main method. Okay, so how do we do this? It's actually quite simple. What you can do is you can use a number, let's say position. See, there's one way you can print the entire sequence, or you can get one particular number. So instead of printing the entire sequence, that is one of your assignment, print the entire sequence, okay? So we can do that. Yeah, but at this point, I just want to go for a particular position. Let's say if if I talk about a position like, okay, difficult to manage two monitors. Yeah. So if we talk about a position like, let's say, okay, so what is this position? So let's say this is 0th position. So this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, and this is 9. So let's say I want to focus on the 9th position. So I want 34. So if someone says I want the Fibonacci at the 9th one, it should print 34. So how do we do this? It's very simple. What you can do is you can say int, and you can have, let's say, position, or we can say pause. So pause is position. Let's say I want the 9th position, and I will save the value in result, and result will be equal to a function will give it to me. So I will say fib. That's my function fib, and fib will take a value which is position, and it will give me a value on that position. So I can simply say is out result. That's it. But then it is the job, it's a job of the fib function to give me the value. So I'll say public static int fib, which will take a value. So it will take int. Okay, now if you're thinking you are new to Java and suddenly I'm writing all this code. So yeah, so Java is one of the prerequisites for this sessions which we are doing, because I'm not teaching you Java from scratch. And in the post as well, I have mentioned the playlist where you can learn, from where you can learn Java. Okay, so we got Fibonacci position. And now here, basically we need to run this function and give one value, right? Now what's the code you will write? Now, as I mentioned, the first two values of Fibonacci is fixed, right? So what we can do is we can save that into variables. Let's say A, it is 0, int B is 1. And then we also need a variable which is C, right? Initial value of C, let's say it is 0. Okay. And now, basically, I want to iterate to a particular position, right? Because I don't want all the values. I want a particular position. So, of course, if you want that position, you have to iterate with a loop. So, you have to go to 0, 1, 2, 3, 4. But since we already have 0 and 1, that's two numbers done. Let's start from the index 2. So, I can say for int I starts with 2. Is everything good on YouTube? Looks good. Okay. And then I less than, okay, should we end at this? I can say pause. Okay, and I plus plus. Okay, this looks cool. We are iterating. And then every time you iterate, I want to find the new value for C. Example, the output I want here is, I want only one value, but the initial value of A and B is 0 and 1. That's done. Then with the iteration, I want 0 and 1, which should give me 1. And then 1, 1, it should give me 2, right? So for that calculation, I can simply say C is equal to A plus B. So I got the new value for C. And then the moment you get a new value, you can just shift your A and B. So you can say A is equal to B now, because we want to shift, right? We want to shift the position of A and B. So we can say A is equal to B and B is equal to C. Yeah, does it make sense? And once you complete the iteration, so after the entire iteration, you are at the 9th position. And once you reach to the 9th position, you can simply say return C. This, yeah. So basically we are shifting between the values, right? And this C will be returned. And this C will be returned here, and it will print it. Let's try. Let me run Fibonacci. Yeah, and you can see we got 34. That's the value we wanted. Example, if I change it to 8 and run, you can see we got 21. Okay, so let me explain the code which I've done here. if I say 3, 5, let me enter all the Fibonacci series, 13, then 21 and 34. Let's reach till this point. So initially, the value of A and B was 0 and 1, right? With me till this point? So value for A and B was 0 and 1. Now once you calculate the value for C, now this will be your C, right? 1 is C because it's the addition of A and B. And that's what we are doing here. Now once we complete this particular operation, I'm switching my value of A and B. So what I'm doing is, I'm switching my value of A and B. So now the value of A becomes 1, which was the value of B before. And the value of B becomes 1, which was the value of C before. And then again you are calculating, you will get to the value of C. And once you get the value of C, again you will push. So the new value of A is 1, the new value of B is 2, the new value of C is 3. Does it make sense? Okay, cool. So this is basically one technique, right? Now what I will do is I will just comment the entire section. This is one technique. But can we use recursion here? The question is, can we use recursion? And to understand this, let me go back to my iPad screen once again. Okay, so in fact, you know what we should do? Before we go for the next example, let's take a small break of 3 minutes because I know we are talking from a long time. So 3 minutes break, we'll continue after that. So give me a thumbs up if 3 minutes break is okay. Okay, cool. So here we go. A 3 minutes break.
Okay. 3 minutes break. 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 3 minutes break.
Okay, I'm back from a break. A small break, I know. Okay, cool. So basically, let's try to understand the Fibonacci with recursion. Now, if we talk about a Fibonacci, let's say we have this number one. I mean, we got 0, 1, 1, 2, 3, 5, 8, 13, 21, 34. Right? We have these numbers. And let's say someone says, I want a position at 9. So again, let's say I want this position. So if you want to reach till this position, yeah. So if you want to reach to this position, what is? So example, if someone says I want a fib of 9, the position 9. So don't you think the fib of 9 is actually fib of 9 is actually fib of 7 plus fib of 8? Is it right? Let me know if this is right. Fib of 9 is actually fib of 7 plus fib of 6, or fib of 7 and 8. So basically this number added with this number will give you 34, right? This is what we want. So basically if you want to achieve this, don't you think we are calling the same function? So inside the fib function, we are calling fib function again. Now you'll be saying, okay, if you want to find the fib of 9, you need fib of 7 and fib of 8. But what about if you want the fib of 7 now? So if you want fib of 7, basically it is fib of 5 plus fib of 6. And if you want fib of 5, you need fib of 4, or fib of 4 plus fib of 3. And if you want fib of 4, and list goes on. Right? So this is also recursion. Now, how do you do this? How do you achieve this? So what I can do is we have commented the entire section. Let me go back to my code again. And let's do this. Let's do this. So basically we got a fib, right? Okay. YouTube is hanging, is it? Okay, cool. Everything looks cool on YouTube. Okay, so what do you want to do? So example, let's say, if we talk about the first two values, 0 position and first position, or instead of saying 0 and 1, let's say 1 and 2. For both the positions, the value will be, okay, no. So for the 0th position, the value is 0, and the position 1 and 2 is 1. So we can check if the position is, if the pause is equal to 0, I can simply return 0, right? Because the 0th position is 0. If the position is equal to 1, or the position is equal to 2, because if you go back here, okay, where I have written the values here. So 0th position is 0, first and second position is 1, so we can simply return 1 here because that's a constant value. But what about this another position? Let's say someone is asking for this position. So this position is the addition of the previous two positions. Even that is simple. I can say return fib of, so let's say if someone is asking for position 9, so it is position 7, or I can say position 8 plus fib of position 7. Does it make sense? If someone is asking for position of 9, I can say position of 8 plus position of 7. See, if you're finding this difficult, you have to try this example by yourself. You have a code with you. I'll try to share this file with you as well in the description once the session gets over. You can rewatch and you can look at my code files and try it by yourself, then it will make much more sense. And also type the code by yourself. It's not just about copying the code and just running it. Try the code. Don't you think this is the thing we want to do? So position 9 is equal to position 8 plus position 7, right? And then the question is what we are doing. We are basically doing a recursion here. Let me just comment this part as well. Yeah. So what we are doing here is recursion. A function is calling a function. Now, will this work? Let's try. Let's run this. Oh, we got a infinite position. 7. Oh, okay. So basically, I'm hardcoding the values, right? It should not be 8. It should be pos minus 1. And this should be position minus 2. Save. Run. And you can see we got 21. 21 for 8th position. Let's say if I say 9th here and run, and you can see we got 34. So basically this is a recursion example for Fibonacci. So basically a function is calling a function. So just to reiterate, what we are doing is, if you say you want a position 9, you need to add the previous 2 positions, and that's what we are doing here. But the problem is, if you want to find the 9th position, you need a position of 7 and 8. But what's the value for 7 and 8? We have to calculate that as well. So even that will be dependent on the previous value. Example, if you want 21, you need to find 8 and 13. And if you want to find 13, you need to find 5 and 7, right? So a lot of things are happening repeatedly. So now my question to everyone here, and the question is very simple. If I want to find the Fibonacci number of 9, okay, let me just share my iPad screen. Okay, so if I say I will, we have to find the Fibonacci of 9. Tell me how many times we are finding the Fibonacci at position 5. Let me repeat my question. If I ask you to find the Fibonacci, in fact, we can also draw it on a diagram. So if I ask you to find the Fibonacci of 9, for Fibonacci of 9, you need 2 things. You need Fibonacci of 7, or maybe I can say 8, and Fibonacci of 7. To find the Fibonacci of 8, you need Fibonacci of 7 and Fibonacci of 6. To find the Fibonacci of 7, you need Fibonacci of 6 and Fibonacci of 5. For 6, basically you need Fibonacci of 5 and Fibonacci of 4. Now same goes on this side. For Fibonacci of 7, you need Fib of 6 and Fib of 5. So my question is, just by this diagram here, if I want to find the Fibonacci of 9, tell me how many times I am finding the Fibonacci of 5. Let me repeat my question. How many times we are finding the Fibonacci of 5? Let me calculate. So we are finding the Fibonacci of 5 here. We are finding the Fibonacci of 5 here. We are finding the Fibonacci of 5 here. And actually, if you go down a bit, even Fib 6, we need Fib of 5 and Fib of 4. Right? So we are finding the Fibonacci of 5 here as well. So 1, 2, 3, and 4. So basically 4 times. In fact, not 4 times. If you go down for this 6 as well, we have multiple Fibonacci. So basically for the same number, we are finding Fibonacci multiple times. Example, let's say if I tell you to calculate something, let's say square root of 16. Now square root of 16 is 4. Everyone knows, right? But let's say if you found that with the help of some calculation, so you worked very hard to find the square root of 16, and again if I ask you the same question, will you again calculate, or will you try to remember the value and you will tell me the value which you have remembered? Waiting for your answer, everyone. So of course, right, you will remember the value. And that's where we get the concept of memoization. What is memoization basically? It simply says, when you are doing all these things, okay, when you are doing all this thing, and if you know, once you calculate the the Fibonacci of 5, you don't have to calculate every time here. Once you get the value, you're done. Let me repeat. Once you find the value of Fibonacci 5 here, you don't have to recalculate here and here and here. So we can use a memory where you can store these values. It's something like cache memory, right? So in this particular code, can we just implement cache memory here? Let's try. So what I'm saying is, every time you find a value of any position, save that in a particular cache, and next time when you want the same value, just get it from the cache. So before I add the code, make sure that you hit the like button and subscribe if you have not done that. Yeah, this is the concept of dynamic programming. So basically, if you're new to dynamic programming, so in dynamic programming, basically what you do is, I'm giving one other example. You take a big problem, you break down the problem into small parts, a sub problem you can say, which is overlapping. So basically, one sub problem can be used for multiple stuff. So you can use a dynamic programming concept there. Yeah, that's right. Sindhu is not just about the number 5. I'm talking about all the numbers. Once you calculate it, you don't have to recalculate. Now question arises where you will store the value. And that's where we got a concept of map. So what is map basically? If you want to store multiple values with the help of a key. Example, let's say what we know till this point is, we know for Fibonacci of 5, okay, I'm not sure what's a Fibonacci for 5. Is it? Let me just get it from here. 0, 1, 2, 3, 4, 5. Yeah, Fibonacci of 5 is 5. So when you know the Fibonacci of 5 is 5, we can just store this in a map. We can say the key is 5, the value is also 5. Example, Fibonacci of 6 is 8. So we don't have to calculate this every time. You can store this value somewhere. Now where to store it? So we can create a map. Map is basically, if you're coming from Python, you know about dictionary. So you store that in a key value pair. So I can say private static, because I want to use them in a static methods. Static map. Map will take basically, so we have to mention what is a type of a key and a value. So both are of type integers. And let's call this as a cache where you store the value. And the way you implement map in Java is with the help of hash map. Okay, Vamsidhar, I think you are still into factorial. Factorial of 5 is 120, not Fibonacci. Fibonacci of 5 is 3, how? Position 5. So 0, 1, 2, 3, 4, and 5. See, everyone have a different way of taking the sequence. I start sequence with 0. So for me, this is 0. This is first position, this is second position. This is third position, this is fourth position, this is fifth position. So let's take a map. Let's import the package for this. Why we got error? Okay, done. Okay, so basically we got this thing, which is map and new hash map. Okay, cool. And what we have to do is, every time you calculate this, you just store this in a map. So what I will do is, instead of returning directly, I can simply take the value. I can say result is equal to, and instead of directly returning it, I can just save this in a result. and then return the result. Same thing, but I just took a variable. And before returning it, just add this to the map. Okay, how do you map? So you have to say cache. And inside this cache, just say put. I want to put a position and the value for it. See, what I'm doing is, every time I calculate the value, whatever the value is, just put that in a cache, which we have created. So we try to remember it. So this time we are implementing a memory. So in the memory, we are saying save the position and save the value. So that next time you call the function should not directly calculate it. The function should try to search for a value in the cache, right? Do you remember it? If you remember it, don't calculate. Example, let's say if I ask you for the square root of 16, first time you will calculate and you will say 4. Next time when I ask you for the square root of 16, you will simply say 4. But if I ask you for a square root of 25, you will say 5. You have to calculate, right? So for the first time, if you're getting a value, you will simply calculate it. And if you already have a value, you can simply use it. Okay, is cache a inbuilt method or something? No, I have created a variable called cache here, if you can see. This is my variable basically. Okay, so every time you do this, so how do you know if you already have a value? Let's check do we have a cache having a value? So cache dot, if you can see, we have this method called contains key. What's a key? Key is a position, right? If there's a key, then simply return from cache dot get, what's the get value? It's pos. So let me repeat what I'm doing here. Every time you call a Fibonacci of a particular number, and if you calculate, just save that in the map. Next time when you want that value, you simply get it from the map, if you have it. Making sense? And this will only work when you already have a value in the cache. If you don't have a value, it will calculate. And after the calculation, now it has the value, it will simply save it. It will simply save it so that next time when you get it, example, if you talk about Fibonacci of 9th position, it will calculate the position of 7 and 8. For 7, we need 6 and 5. For 6, we need 5 and 4. So once you get 5, you will store that in the cache. And next time, if you need 5, it will just give it from the cache. Is it making sense? Let's try. Let's run this code and it works. You can see we got 34. And if you say 8, and you can see we got 21. Makes sense, right, everyone? So this is memoization, where you are remembering the values. Yeah. Now the question is it really faster? The answer is no. It's not that fast. At least for Fibonacci, I'm not sure is it fast, but it can be used for different use cases. I could have gone for a complex use case, but then learning a concept and then going for a complex problem will again create more confusion. So the idea was to teach you how to think about recursion and memoization. Yeah. Cool. So don't worry, I will share the code with you. Okay, you want me to try it for 3. Okay, let me try. Position is 3. You can see we got 2. So third position is what? If you go back, we have the values here. So 0th position, first position, second position, third position. Yeah, actually, Chandra says it will keep getting faster. That's right. If you have a bigger sequence to find or a bigger number to find, then yes, it will be helpful. Okay, let me know in the chat for how many people the concept of memoization was new. Okay, Om there says new to me. Cool. If you enjoyed this example and concept, hit that like button. Of course, it's very difficult to teach all this thing in 1 hour or so, but I tried. And of course, this will make much more sense once you try the example by yourself. Okay, so we have talked about recursion. We have talked about how do you do factorial with recursion. We have talked about Fibonacci with loop and recursion. We have seen what is memoization. We have tried Fibonacci with memoization. And now it's time for assignment. So basically, I will give you a problem statement. You have to solve that by tomorrow, before next session. So before next session, you have to submit the assignment. Now, how will you submit the assignment? First, make sure that you have a remote repository. It can be GitHub or GitLab. Okay, don't tell me you don't have a GitHub repository. Come on, we are into a world of programming. You need a remote repository. GitHub, GitLab doesn't matter. Okay, you have to write your applications, softwares, programs, and make sure that you put that in the repository, and then share the repository with us. How will you do that? We also want to see that the thing is, with the help of ChatGPT, with the help of all AI tools, I know if I give you a problem statement now, you will go to ChatGPT and you will type the problem statement. ChatGPT will give you the entire code and you will say, hey, okay, I have done my assignment. No, I'm smart. So what you do is, on LinkedIn, you have to share your GitHub link. So create a LinkedIn post, share your GitHub link, but also explain the concept. If you can explain the concept in your own words, and if you are consistent with your words throughout these 10 days, then it will be considered. Okay. And also, if you're not doing this for Macbook, do it for yourself. See, LinkedIn is actually a very famous platform. If you want to get a job, or if you want to get notified, if you want to grow your profile. So even if you want to grow in your career, you need to make good connections. You need people who will trust you. So make sure that you are active on LinkedIn, and that's where a lot of people will connect with you. So yeah, LinkedIn or YouTube, both works. So, but explain the concept. Okay, what you should publish as an article, explain the concept. Whatever assignment I will give you now, explain the concept and also tell what was your approach. See, every problem have a different solution. It's not like you only got one solution for the problem. There are multiple solutions, and whatever you think, just share that. Does it make sense? And now let's talk about the assignment, the actual assignment. So before we go for the assignment, hit that like button, everyone. Very much needed. Come on, that's where I get the energy. Okay, so what is the assignment? Let's talk about the assignment. So assignment is Pascal triangle. So basically you have to write a program to print Pascal triangle with memoization, and with recursion and with iteration. So basically there are 3 different codes which you have to do in different format. Now, what is Pascal triangle, you will ask? Okay, so basically Pascal triangle is again a mathematical problem, which is, so that's how it looks like. So 1, 1, 1, 1. And then if you want to create a next row, you need to get, it will always start with 1, end with 1. The next values depend upon the initial, the above values. 1 and 1 is 2. Then again, it starts with 1. Then how will you get the next value? It is this value and this value, which is 3. The next value is this value and this value, which is 3. And the next value is 1. Always starts with an 1 and ends with 1. And then it starts with 1. Then 1 and 1 is 4. So 1 and 3 is 4. Then 3 and 3 is 6. 3 and 1 is 4. And then ends with 1. This is the Pascal triangle. So build this with all. And submit this before the live session, next live session, which is tomorrow, 9 p.m. Okay, now the question is, do the assignments have language barrier? Okay, so we can open it for 2 more languages, Python and JavaScript. Because at this point, I only know those 2 languages. If you try with something else, it will be difficult for me to understand the thing. So you can complete the assignment in JavaScript, Java, and Python. Yeah, that's right, binomial theorem. Okay, yeah, by typing, of course. Yeah, we should do that in binomial theorem. Through that. Okay, now I'm open for questions. Okay. It's already been 72 minutes and we are still alive. Come on, questions. Can we post assignments in YouTube? No. Okay, people who want to participate in this contest, very simple. You will find the link in description. You have to fill the Google form. So what's the plan for tomorrow? Mostly we'll try to build a project tomorrow. I have one project in my mind, which is inventory management, because we want to understand the concepts of Java more, right? So in fact, I have a list with me, what I have planned. Okay, notes. So we want to build a project. There will be some sessions where we'll focus on the interview questions. In fact, memoization is also one of the interview questions they ask. And then in some of the video, we'll talk about reflection API. In some session, we'll talk about Lombok, which is a fun library to use. We can also do, one of the sessions, we can have a roadmap of how to learn Java, how to be a Java developer. And it's time for the course update, the promotion time. So basically, we are coming up with a Java course, the live Java course. That will be paid one. This is a free sessions which we're doing. But that's a paid course, and it's starting from 4th of June. In fact, once the session gets over, I will play the video once again to get all the details. Or you can go to you can check the description area. In fact, for today itself, we are offering 50% off only for people who are watching the live session. And that too, only 10 enrollments, first 10 enrollments. So check out the course link in description. Okay, so also let me know your feedback. How was the session? Did you enjoy it? Cool. Where to post explanation on your LinkedIn. So create a post, a LinkedIn post, and explain there. Cool. So thank you so much, everyone, for joining. See you tomorrow, and keep attending all the sessions to win the MacBook. MacBook Air is on the way. Thank you so much. Bye-bye.